I'm Phillip Miller, VP of Product Management at Chaos. And this is our GTC 2021 session on From Production Rendering with V-Ray GPU to Real-Time Ray Tracing with Chaos Vantage. I'll be joined today by Aleksander Angelov, our team lead of V-Ray GPU development, who will be describing the latest advances in our V-Ray GPU renderer. We'll also be joined by Simeon Balabanov, our product manager of real-time solutions, who will be giving us a tour of his new product, Chaos Vantage. If you're unfamiliar with Chaos, we're a company completely dedicated to developing 3D rendering and simulation software, mostly within professional 3D creation tools, which in turn are used by the world's leading companies creating design visualization and visual effects. Earlier this year, we introduced real-time solutions and the Chaos ecosystem across many of our rendering products, which will eventually extend to all of them. This new level of possibility and interconnectivity we felt deserved a new way of presenting the company. We used to be called Chaos Group. We are now simply Chaos. And we feel that our brand now reflects better the amazing creativity of the many artists and designers that use our products, with the following being an example of that. Welcome to Chaos. So as that shows, visualization is everything, from the products that you use to the entertainment that you watch. To make that possible requires very high quality software from our side, as well as, of course, the talent of our many users, who then require power. They require their products to stand up to the rigors that their designs and creativity are pushing on the system. And with that, they need speed. They need speed to speed the creative process. And that's why we're here talking about GPU acceleration at GTC. At Chaos, we are committed to GPU ray tracing in multiple ways. We have our V-Ray GPU renderer, which delivers film quality results across all of our 3D creation tools that we support. And now we have Chaos Vantage, an independent product delivering real-time ray tracing that interconnects to all of the creation tools where V-Ray GPU is. We're often asked, why be doing all this when you have V-Ray? V-Ray is an Academy Award-winning renderer, most widely used professional photorealistic renderer in the world. It's because we feel that increasing artist efficiency is just as important as the capabilities of the renderer. And this plays out all the time. And this becomes all about speed, which in turn means GPU acceleration. Because if we can give faster rendering, it means the artist gets faster feedback, they can make faster decisions, they can do more iterations, they can explore more and get better results. So as a result, you get better images, you get better animations and everything else if we provide the speed. So we do that first by taking advantage of all the processors in the system. V-Ray GPU will use all the CPU cores it finds, as well as all the CUDA-capable GPUs it finds. As I mentioned, we're fully accelerated on CUDA, so all the generations of NVIDIA hardware, and then we take extra advantage of the latest RTX GPUs. V-Ray GPU is the first renderer to take advantage of NVLink, and we support all of its permutations today, allowing you to pool the memory across GPUs for handling the largest scenes. Now, what's important in all of this is that you never have to worry about getting a different result. We deliver the same images regardless of what processor you're running on or combination of processors. This gives artists a lot of flexibility and confidence. They can work on their local workstation completely with GPU acceleration to make really fast decisions, and for example, send it off to a CPU-only render farm and be guaranteed to be getting the same results they saw on their workstation. Now, if you come to our website, you'll see many products, and V-Ray GPU isn't listed. That's because V-Ray GPU is wherever V-Ray is. So if you're getting V-Ray, V-Ray GPU is an option there. Sometimes it's a separate renderer option, sometimes it's simply a GPU checkbox, but it's always there. In addition, it extends to our services for cloud rendering as well as using models. And also to our simulation software and render farm support. And recent news on our V-Ray for SketchUp product. As of last week, V-Ray is now part of Trimble's SketchUp Studio. SketchUp Studio includes SketchUp Pro as well as additional capabilities, V-Ray now being part of that. In addition, every single trial of SketchUp Studio that is shipped actually starts off as Studio. So that means that thousands of new users have access to V-Ray GPU every single day. Now I'd like to segue over to Aleksander, who will go more in depth onto V-Ray GPU.
Thanks, Phil, and hello everyone. V-Ray GPU has supported RTX since it first became possible in November 2019 with the release of Optics version 7. It is supported everywhere where V-Ray GPU is supported, so in every V-Ray 5 and V-Ray Next products we offer. Also, you could use RTX to render in the cloud, where we use NVIDIA T4 video cards. V-Ray GPU supports RTX seamlessly, which means our users does not need to do anything differently than before. They could use the same data and same workflow they have used before, and everything just works. V-Ray RTX and CUDA engines share 99% of the GPU side code base, so everything that is implemented for CUDA is implemented for RTX as well, without any additional effort on our side. So this means that our RTX support is very stable and consistent between CUDA and RTX, so our users does not need to worry about unsupported features in RTX mode. Also, every render is identical between RTX and CUDA for the GPU, and also as we have a CPU mode running on x86, the renders are identical there as well. Which mode is faster really depends on what kind of scene do you have. Is it geometry heavy, texture heavy, and so on. So we encourage our users to make experiments and try different modes, either CUDA, RTX, or CPU rendering, and to check for their scene what is working best. What we have promised last fall at GTC was out-of-core rendering, light cache support on the GPU, support for chaos cloud rendering with GPUs, faster startup times, and faster CPU renderings. What we have delivered in our latest version, V-Ray 5 Update 1, out-of-core rendering is almost done. We now have light cache support on the GPU. We have chaos cloud rendering. As for the faster startup times and faster CPU renderings, those are continued efforts that are in progress. Our out-of-core implementation now supports all V-Ray GPU capabilities, which means we support on-demand loading and eviction of geometry when rendering, so our users can use very large scenes without worry about them fitting on the GPU memory. Out-of-core supports all ray casting textures we support in V-Ray GPU, like dirt, rounded corners, etc. Also, we have support for V-Ray Clipper, which is Boolean geometries at render time. And what is left for us to do is automatic geometry subdivision, so that large meshes could be paged in at smaller chunks, and all of this should happen without the user intervention or any user action. And the last part of before out of core is finished is out of core textures. So we should have the same mechanism for loading, on-demand loading, and eviction for textures as well. We have many challenges with out of core, and we have overcome them, and some of them are about textures that could spawn rays, like the dirt texture, for example. How we have handled that is when we hit an object that needs such textures, we before starting the shading phase, trace all those additional rays needed to calculate the dirt texture. We store the results and then go into the shading phase, where the texture itself could just use the already calculated results. This was needed to be done because we need to be able to load missing geometry, and this to be done inside the shading phase would be too hard, so we needed to move all our ray casting before the shading phase itself. Another challenge proved to be the V-Ray Clipper. As it's currently implemented, it spawns a lot of rays in different directions in order to determine whether we are inside or outside an object, so it should know whether to clip it and how to shade it. All of those rays could possibly hit a geometry that is not loaded in memory, so this proved to be difficult to implement. And so what we have done is split the whole Clipper implementation into multiple kernels that are called one after the other, and we have made such split so that we could support loading the geometry when we need it. Light cache is a way for us to accelerate GI computations at render time. It works in a pre-path that calculates many paths which have large trace depth and records the radians along the path, and this is recorded in a 3D structure. Afterwards, at render time, we sample this 3D structure instead of calculating GI. This way, we can speed up renders a lot. So, before, we have used the CPU engine, the V-Ray itself, to calculate this light cache. So we had to load the whole scene into CPU memory and have CPU representation of it, and then use the CPU engine to calculate the light cache, and then transfer it to the GPU, and only then we could start the GPU render and using this light cache. With our latest update, we have implemented GPU light cache calculations. So everything now could be calculated on the GPU. So we no longer need to have a CPU site representation of the scene, and we could generate the light cache a lot faster with higher quality using the GPU itself. Also, this allows us to use light cache in IPR interactive sessions, so the user could have better lighting clarity while moving through the scene and making changes. Also, before, the light cache preview was using the CPU engine and could show subtle differences than the final render, which used the GPU, as they're both different engines and have some minor differences. And now the light cache preview will be the same as the final render, as they are using the same engine. As an implementation detail, the GPU light cache calculation is using a new architecture called kernel tree. Here is a video showing an interactive session inside 3ds Max, first without using GPU light cache and afterwards enabling it. As you can see, the results are much faster to generate and less noisier, so it's much better to use light cache. Kernel tree is our new kernel architecture. It is enabling us to do out of core. In itself, it is a multi-kernel architecture, which means we have different small functions on the GPU, which are called kernels, which we execute in succession. So we have a kernel which traces rays, just traces rays, then another kernel which just shades them. And this is opposed to our kernel architecture called kernel 2, which is tracing whole paths. So it is calling trace and shade in the same GPU function. The multi-kernel architecture is easier for us to optimize and extend, as every kernel itself is smaller and easier to reason about. However, it is harder to debug, as when there is some problem, you need to track through different GPU function executions, which is harder to do. These new kernel architectures enables us to do to trace bigger depths for our paths without having to allocate any additional video memory. This allows our users to have better transparency, reflection, and refraction effects without having to resort to bigger GPUs. For example, the current GPU light cache implementations is using 100 GI bounces, which was not previously possible with our current architecture. As already mentioned, kernel tree is currently in production with the GPU light cache. Now I want to talk about some of the research and development we are doing at V-Ray GPU. One of it is concerning out-of-core textures. So our current implementation for geometry is when array hits a geometry that is still not loaded or not present into GPU memory. We make a request for it and then exit the kernel, load the data on the CPU, and then we execute the kernel again, which will make all the calculations again and would progress further as it now has all the needed data. And then again, if we hit something else which is not present in the GPU memory, we exit the kernel, load it, and then call the kernel again. However, textures are used at many places within our shading pipeline, so it is very difficult to make the shading kernel reentrant. So it is not possible for us just to exit the kernel, load the data, and call the kernel again, as a lot of heavy calculations needs to be done again, which is not desirable. So we have started experimented with a new approach where while we are inside the shading pipeline and we encounter a missing texture, we make a request for it on the CPU, and we start waiting for the CPU to load the data actively on the GPU itself using atomic functions. In the meantime, there is a special CPU thread that is waiting for requests, and when one such arrives, it will load the needed GPU texture data and send it through the PCI bus to the GPU, and then the GPU will continue from where it was with the needed data. This will allow us to not make a lot of changes to our shading pipeline and to support out of core very easily. And we hope to show you progress at next GTC. Another thing we are looking at is about volume rendering. NVIDIA NanoVDB is a library which provides efficient GPU storage for volume grids, which we use for volume rendering of smokes, waters, and such. We have already integrated NanoVDB inside V-Ray GPU, and we are actively testing it. And our current results are that NanoVDB is taking twice as much memory than our current code. This is due to NanoVDB internally using 32-bit floating point precision values, as our code currently is using only 60-bit precision values. And also, we currently do not support sparse volumes in our GPU rendering code, so we make all our sparse volumes into dense ones. And so we do not see any much gain from using NanoVDB itself. However, our next steps is to remove the requirement of a dense volume, and after that is done, we could start using NanoVDB more efficiently, and it would allow us to render huge datasets, some from very huge simulations which are sparse, and we could render those as before we could not have fit them into the GPU memory. Going forward, we will finish our out-of-core implementation, which will mean that we will implement out-of-core textures in production with on-demand loading and eviction. Currently, only GPU light cache and out-of-core mode are using our new kernel 3 architecture, but we will move all our rendering to kernel 3. And also, there are additional features that just landed in V-Ray 5 update 1 for the CPU engine, like a new translucency model, which is yet to be implemented on the GPU. That was all from me. Thanks everyone, and back to you, Phil.
Thanks, Alex. I'd now like to take a minute to go over the performance results we're seeing on Ampere GPUs with our ray tracing products. So, with V-Ray GPU, we're seeing a 2x generational improvement when using CUDA, and when using the RTX mode, we're seeing a 2.5x generational improvement. We think that this difference in the speed is primarily due to the RT cores, with RTX mode being able to take advantage of the RT cores because it uses optics, whereas CUDA is not allowed to use the RT cores. We're seeing a similar speed up with Vantage, 2.5x generation over generation from Turing to Ampere, similar to what we were seeing with RTX on V-Ray GPU. And if we take a look back to when there wasn't RT cores, back to Pascal generation, then we're seeing a 4x improvement to Turing and a whopping 7.4x improvement from Pascal to Ampere. And this, we believe, is clear evidence of the benefit RT cores are delivering the GPU ray tracing. Now, you may have noticed that Vantage is 4x faster from Pascal to Turing, while V-Ray GPU is only 2x faster. Now, basically, this means that Vantage is getting double the benefit from the RT cores than V-Ray GPU does. There's some ways of handling data that this impacts, but primarily we think that this is due to the fact that we designed Vantage with RTX in mind. And so we maximized its ray usage while minimizing its shading. And we feel that this is the real reason that we got twice the impact from RT cores rather than just the DXR API that it's using. But the result is amazing. With a single RTX 3080 now, you can get 30 frames a second at full HD with hundreds of millions of polygons. It's a dream come true for designers. And here's a quick overview of what it's like to use Vantage.
An all-new way to explore detailed 3D scenes in high-quality real-time. Chaos Vantage can handle scenes of any size, even the most detailed cityscapes. It's effortless to set up too. Use a live link with 3ds Max, or simply drag and drop your V-Ray scene file to start exploring in real time without any model preparation or light baking. Changes you make in your Mac scene, like changes to lights, cameras, and materials, are all updated live in Vantage. Set up and save as many views as you'd like, and automatically transition between views for powerful interactive presentations. Chaos Vantage is the fastest way for you to explore your 3D production scenes in high-quality real-time. Get started today.
So that gives you an idea what it's like. What makes it super special is that it's 100% ray tracing all the time. Vantage uses no rasterization whatsoever. What this means is that there's no slowdown from adding additional geometry, and it can handle enormous scenes like this one of New York City here on the left by Neoscape. Because it can handle such large original data, you also don't spend any time optimizing. There's no need to. Finally, there's also no preparation time for materials or lights, no conversion. Vantage takes exactly what you've been using for V-Ray in the creation tools. And finally, it creates a consistent experience for your scenes, regardless of where they're coming from, whether it be Max, Maya, Houdini, SketchUp, wherever. Everyone has the same experience bringing that model into Vantage. And right now, it's currently free. You can get a complimentary one-year license until June 2nd of this year. Here's a great example of that same city scene being navigated, and now you can actually see how much rich detail is actually within that model. This animation actually goes on for well over a minute, where you can see 3.25 billion instance faces, how much detail that really is for such a large model. And all of this fits within a single GPU memory, 24 gig. Also, here's a quick example of what it's like to work in live linking in the sense that in the upper left is 3ds Max, what you normally see when you're modeling, and the lower right is the same scene in Vantage live linked. So now you're modeling in the left, and you see what it's like here. It's a modeler's dream come true. We're going to be bringing this capability to other applications where V-Ray is later on this year. So more live linking will be possible in products like Maya, for example. This setup works really well with dual monitors, putting the creation tool on one and Vantage on the other. Also works really well with dual GPU or even 3 GPUs, where one is for graphics and the other 1 or 2 are for Vantage GPU ray tracing. Vantage also works really well in many remoting solutions. People are using this all the time right now, either remoting into a more powerful machine themselves or sharing their screen with others for collaborative design reviews. It's working great for people. Some design considerations we had when creating Vantage was that since rays are practically free on RTX, it liberates us to do a lot of things. First of all, there's no baking. We do everything all the time universally. So reflections, GI, and so on are just automatically calculated. Things like collision detection are easy. Same things for detecting floors and ramps and stairs when navigating. We just shoot rays, we know where they are. Also, simple things like hit testing or overlays or more advanced rendering effects, all much more easy when they're completely ray traced. But this is just an overview. I'm going to hand it over now to Simeon to go more into depth into Vantage.
Thanks, Phil, and hello, everyone. I'm going to do a quick demo of the Vantage workflow together with LiveLink from 3ds Max and the newest editions. To demonstrate that, I have a scene from Evermotion, and I'm going to start the LiveLink. As you can see, the scene is fully interactive now, and I can navigate within Vantage, but if I scrub the time slider, I also have an animation, and that gets updated. In this case, I have a time-lapse of the day, and I'm going to transfer this in Vantage later on. But first, let's tackle a few things. Currently, the light here is way too strong. Let's see the slide setup. We have a few different sets of lights, and different layers. Let's move this out of the way. So I'm going to lower the highlight burn value to something about that, 0.3, 0.4, to get rid of the overbrights over here. And I'm also going to turn up the clamping so that we allow a bit more light in the image. Then we can continue modifying this in Vantage, but one thing we can't do is adjust materials. So I'm going to do that. Let's close up in this guy here. and open up the material editor. I have a metallic shader over here, and if I want to change the color, I can do that right there. So let's make it more saturated, a bit more goldish, or less saturated. Let's have a look at the whole image. And yeah, that will do. Let's close the material editor. And I'm going to now transfer the whole scene, which is animated, using the button from the toolbar. And now the scene gets loaded in Vantage. Let's continue working in Vantage alone. Now again, the scene is totally interactive and the animation is over here. Let's reset the camera, and you can see the highlight burn has been kept. We don't need to readjust it again. And we have the nighttime setup, daytime setup. Okay, let's position that. Right, so I'm free to look around the scene. I'm going to increase the width of the resolution so that it looks better. And I can also validate the design by exploring the space in this first-person mode. I can also perform some scene modifications, and to show that, I'm going to add a few assets from the Chaos Cosmos library that we integrated in our latest build. Let's pop up the browser and resize. And here is the browser. There are a few categories like furniture, accessories, lighting, people, vegetation, vehicles, but I'm going to add a few accessories here in the tableware and food category. Yeah, this picture looks nice. Let's download that and drag and drop it on the table. Okay, and it's been added to the objects list. Now we can modify it freely. Let's rotate it a bit. Okay, and put it there. Free some space. Yeah, that looks nice. Let's add something else. Probably this time from the accessories. Let's add a cushion or a pillow. Yeah, this one. And I'm going to put it over there. Reposition that because it's currently going into the furniture. Oops. Yeah, it's like so, right? And finally, I have downloaded a watch. This guy here. Let's put it on the wall. And let's make sure that it's aligned properly. Just zoom in and see if it's aligned properly to the wall. Right. Yeah, I need to rotate it just a bit. Okay. Oh, we need to bring it up. Right. Yeah, and let's scrub the slider again. Yeah, it looks nice. Close the Cosmos browser. And I think we can add a bit of post-processing here. Let's select one of the LUT files that ships with Vantage. This one is a bit colder. I'm going to try with that. Yeah, it looks nice. But now I can bring a little bit of the warmth through the white balance. That was a bit too much in the night shot, so let's bring it back. Okay, validating the whole animation. Right. Let's play it once more, a bit slower this time. And this way I've balanced the image across the animation. However, I feel that this image will look much better if it's more warmer. And I'm just going to get rid of the cold LUT and just apply a bit of white balancing here using the temperature slider or some of the presets that are in the color picker. If I would like to do a quick review of this shot and share it with somebody, I can capture the viewport really quickly with this option and play back the animation, or even walk through and capture that. But I can also create a camera animation and render it out with even higher quality for a better pre-visualization. So let's do that. I'm going to set a camera in the beginning of the frame, and I'm going to slightly zoom in or dolly the camera forward. Yeah, create another key or another camera, drag those here on the timeline, add a transition between those, And I'm going to shorten the clips, the keyframes in the beginning and the end by making them transient, and make the animation longer and preview that. Using this approach, I've rendered a few higher quality sequences, and here is the result. Thanks everyone. Back to you, Phil.
Thank you, Simeon. I'd like to now introduce you to the latest real-time solution from Chaos, and this is V-Ray Vision. V-Ray Vision started shipping recently for SketchUp, Rhino, and most recently Revit at the beginning of this year. V-Ray Vision is a real-time rasterized view, so we're no longer talking about ray tracing. It runs cross-platform on modest hardware. It provides a really high-quality approximation of the V-Ray materials and lighting you're using in your scene. It's lightweight enough to always be running while you're modeling. For example, in the upper left here would be like a SketchUp viewport, and the other one would be Vision. You could have that up and running all the time while you're working in SketchUp. And you can switch to V-Ray rendering at any time without any additional work. What you've been doing in Vision and seeing will automatically move over into V-Ray for higher quality. Now, while this is fully rasterized, we are looking to add ray tracing effects in the future for those with RTX hardware. Now, to give you a bigger view of this would be your normal life within SketchUp as you're working and modeling. This is the exact same view with V-Ray Vision that you could have up side by side with your SketchUp modeling world, and then you can switch over into the full quality of V-Ray at any time. So what this is really doing is it's setting up a continuum for materials and lighting across Chaos products. Starting with those using V-Ray and V-Ray GPU, we start with the highest definition of what's possible, and from there we allow the real-time solutions to interpret as best they can. This happens automatically for users with no extra work on their part, and it's providing a complete consistent way basically to go from real-time to film at any point. So thank you for attending our session. We hope you enjoy the rest of GTC 2021. Thank you.